Hey everyone, today's lesson is about the rules of entropy, specifically those associated with spontaneous and non-spontaneous processes. Today's goal is to list the conditions in which we get a positive or a negative entropy value. The first rule of entropy states that the entropy increases as the state of matter changes from solid to gas. For example, when carbon dioxide is gas, then it has a higher entropy value than that of the solid form. In this diagram, we can see the relationship between entropy and temperature, and we can conclude that when we increase the temperature, the entropy value increases as well. The second rule of entropy states that particles in a solution have a higher entropy than solids. For example, when it comes to sodium chloride, its aqueous solution has a higher entropy value than the solid form. And here is another example of the second rule of entropy. When we put salt in a water solution, the disorderedness of the arrangement of the molecules and the ions will increase, making the salt dissolve in the water. The third rule of entropy states that liquids have lower entropy value than particles in a mixture. Here, we can see that the randomness have increased in both examples. Firstly, when we combined solid and liquid, and secondly, when we combine two different mixtures or solutions. The fourth rule of entropy states that the entropy would increase if the number of molecules of gaseous reactants was lower than the number of molecules of gaseous products. The fifth rule of entropy states that temperature and entropy are directly proportional, meaning that if we increase the temperature, the entropy would increase as well. For example, water has a higher entropy at 80 degrees Celsius than at 25 degrees Celsius, and this can be justified by the randomness and the rate of movement of the particles. Here is a visualization of what we just explained. The sixth rule of entropy states that volume and entropy have a direct relationship, while pressure and entropy have an inverse relationship. Therefore, if we increase the entropy, the volume will increase, but the pressure will decrease. And the example given is a further elaboration of the topic discussed. The seventh rule of entropy states that the larger and complex a molecule is, the larger is its entropy value. For example, the entropy value of C6H6, widely known as benzene, is higher than the entropy value of sulfur dioxide, which in turn is higher than the entropy value of helium. When it comes to single atoms, the absolute entropy would change according to the mass changes. Therefore, if we increase the mass, the absolute entropy value would increase as well. For example, the entropy value of diamond is lower than the entropy value of graphite, and this can be explained by the number of protons and electrons in the atoms themselves. And finally, when it comes to elements, the entropy would increase as we increase the atomic number. In this section, we will predict the sign of delta S according to the changes happening within the reactions. Here, in the first example, the entropy has decreased, so the delta S would be negative. And all of this is based on our very first rule of entropy that stated that gas has a greater entropy than liquids. Knowing that a solid has a lower entropy than a gas, we can conclude that in this example, the entropy has increased and the delta S is positive. And here the delta S would be positive because the entropy have increased, and all of this happened because the number of moles of gas has increased in the reaction given.